Hello, my name is Andre Trixa, and for my Renewable Resources 580 course project, I will be assessing the reliability of two-flux FA-PAR. First of all, we must ask ourselves, what is FA-PAR? It stands for fraction of absorbed photosynthetically active radiation. The last part, PAR, is the solar radiation in the range of 400 to 700 nanometers. FA-PAR is the fraction of that available PAR absorbed by the vegetation. The importance of FA-PAR is very well described here in the slide with a quote taken directly from the website of the Global Climate Observing System, who hold this variable in such high regard that it has been deemed an essential climate variable, or ECV. This is the current way we measure in situ FA-PAR. In this study, values measured from this calculation with these sensors are considered true values, as they have proven in the past to be a reliable source for the ground measurement. This can lead to quite the headache in the field, as an intricate and sophisticated setup with all these sensors can be very labor and cost expensive. PAR is the responding variable and the new methodology we are testing in the study. The transmitted PAR sensors are located in the forest, while the incoming PAR is in a nearby field where tree canopy cannot interrupt the incoming solar radiation. Should this method prove to be reliable, it would be a more cost-effective and labor-effective method for in situ FA-PAR measurements. Here's a look at both methods side to side. This really shows the simplification of FA-PAR from our original method to our testing method, where only two variables are used. Based on a past study done in the evergreen forest of Germany, we expect that two-flux FA-PAR shows to be a reliable source of ground measurement. The study area for this project is Santa Rosa National Park in Costa Rica, located in the northwest corner of the country. The biome for this study is the tropical dry forest. On this map, you can clearly see the points denoting the location of the wireless sensor network. You may notice one point is clearly separate from the rest. This is the incoming solar sensor, which is taken in a field, not to be blocked by forest canopy. You may also be wondering why we did not bring the other sensors closer to the incoming solar sensor, and this was a conscious decision with the hopes of diminishing horizontal fluxes. In this study, all sensors were set at a height of 1.3 meters. With 4 transmitted sensors, 4 measurements were being taken at a time, from which the average was then calculated. This study took place from April 30th to July 9th of this year. Measurements were recorded in intervals of 15 minutes using data from around noontime to avoid too much variability. In addition, any datum with a ratio greater than 1 or a negative ratio was deleted, as this is clearly flawed. Here's a quick look at the data I input into R. Here are the initial distributions of the FA-PAR data for the true and test data. As we can see here, the data is not normal. The true data is heavily skewed to the right, whereas the test FA-PAR data is bimodal. It must also be noted that the true FA-PAR shows some bimodal tendencies, but not nearly as obvious as the test FA-PAR. Since this is a comparison question, we must also acknowledge that the distributions do not resemble each other. Data is deemed not normal based on the distribution analyzed in the previous slide. The following descriptive statistics would be more fitting than the mean or standard deviation. As you can see, the medians are quite different, as well as the ranges. This is shown in the box plot. The analysis I conducted was plotting my test FA-PAR to my true FA-PAR. If two-flux FA-PAR were reliable, you would expect there to be a high R-squared value showing correlation between the values. However, this is not the case, as R-squared is only at 0.3437. Based off these descriptive statistics and graphs, we can see that two-flux FA-PAR is not a good substitute for FA-PAR measurements, at least not in Costa Rica's tropical dry forest. This is visible in the difference in distribution as shown in the histograms, the different medians as shown in the box plot, and the low R-squared values as shown in the scatter plot. It is possible that this low reliability could be due to the different light fluxes, such as horizontal or albedo, being too high for it to be ignored, as is the case in two-flux measurements. This brings me to my conclusion. that 2-flux FAPAR has not proven to be a reliable source for in situ FAPAR measurements.